Alright, welcome class. Today we're going to learn about Newton's second law. Alright, his law, this one's different from all of them. It's not one of them word laws. It's one of them math equations. F net equals ma. Alright, I got my best friend, Mr. Tang here. I flew him out from China all the way to Morgan Hill to teach you about this. Alright, I can't teach this because vectors, it's not my thing, nor this math equation. It's too hard for me.
Okay, so for a vector diagram, this describes what is happening to an object. So when you're pushing an object, there's friction to it, so this is part of the negative direction. And when you apply force, it's part of an implied force, so that'll be called F1 or whatever variable it's called. And there's also gravity applied to it, so there is a negative direction to the actual object. So that is 9.98, and you multiply that times the mass, and you get F gravity, and you get F normal force, which is going against gravity. Got that, Mr. Sickle?
Yeah, I got that.
Got that?
Okay. Alright, while Mr. Tang was explaining this, he brought up a key point, and one of them was force of gravity. He basically used the equation here. So, our equation is F net, which is the total forces in the system. That's why we draw a vector diagram, so we know where all the forces are. And if they cancel out, is equal to the mass of the object and the acceleration. And we know the acceleration on object that's being pulled down is 9.8, which is the acceleration of gravity. But we don't like to make math with all very complicated, messy with all the decimals, so we say it's 10. And from there, let's say our mass is 5 kilograms. Mass is equal to 5 kilograms. It's 105. From there, we can find the force of the object being pulled down with. So force is equal to 5 kilograms times the acceleration. And we get a total of 50 newtons. Force is always in newtons. Alright, now that we showed you how to use Newton's second law, let's use it in real life example. Let's say I was like playing around with my daughter Clarice, and I decided it would be fun to put her up on the whiteboard. Now let's say I'm trying to figure out how much force she's going to fall with. So we know her mass is, let's say 15 kilograms. A nice number. Alright, the acceleration of gravity, because it's falling, is 10 meters per second squared. Now let's draw our vector diagram. Alright. We have the force of gravity pulling the baby down. But this time there's no normal force because there's nothing holding it up. So this is the only force that's being applied on it. Alright, plug all our numbers into our equation now that we figured out there's only one force in the system. Force F net is equal to 15 times 10. So her force, while she's falling, is 150 newtons. So she's going to hit the... Hey! Who threw that? Do I need to call your mama? Your mama's going to settle you out, alright? Alright. Force is 150 newtons. And she's going to hit the floor with that much force.
Okay, so now with knowing that
You suck! Hey! I'm gonna call your mom right now, alright? Sonny, go sit in the corner now. No, I'm not gonna throw it at you. Alright, we're in a different room right now because Lil Bob thought it was gonna be funny to bring a couple firecrackers from home and set them off. And I'm a bit down right now because I lost my accent because of all the fumes from the firecrackers, but it's alright. I'll continue teaching y'all physics. All right, before we had to evacuate the room, we left off with Clarice, my daughter, and we said, if we put her on top of a whiteboard, how much force is she going to be falling with, or how much force she's going to hit the floor with? And we came up with a total of 150 newtons. And from there, we can find the velocity to show you all how physics, all the concepts within physics are connected. We're going to find the velocity of her speed when she was falling. And to do this, we're going to use a couple of equations. We have work over here, and we have kinetic energy. And we know that energy in a system is conserved, so the total amount of energy you start out with is the same amount you're going to have at the end of it. So with the help of my friend, Mr. Tang, he's going to show you all how the math is done.
One thing that we can find out from using all this information, that is work. So from work, we have the formula force times distance, and from where the baby was being, where the baby was about to fall down, the baby was about to fall down 2 meters, so we can plug that in for distance. And we have force, which was given by the force of gravity, which was mass times acceleration. So we found out that the baby was 15 kilograms, and that is being multiplied by 10 meters per second squared, which got us 150 newtons, and we can plug that into the work equation, and we got 150 newtons times 2 meters, which will give us work will equal to 300 joules. That's the unit for work, joules. And now Mr. Tinkle will finish it up for us with kinetic energy.
All right. Thank you, Mr. Tang. All right. Now that we found the total energy in the system, we can apply this. So E total is equal to E final. So if we're going to find her velocity, we're going to use kinetic energy. And with energy, energy can be changed into anything. It can be changed into potential energy, which has the potential to do something, kinetic energy, something in motion. For this instance, we're going to use kinetic energy. So we're going to plug in 300 into our equation. 300 joules is equal to the final minus initial velocity. So weight 15. Velocity we're looking for. But because she was at rest, we can say minus 0. Because she has no speed initially. And then we should get, what is it? 300 divided by 30. We should get velocity of 3.2 meters per second. So this is her speed when she's falling down. All right, I'm sorry class, but I think this is all the time we have for today. Hopefully you learned something. Maybe you shouldn't put your baby on top of a whiteboard, or else maybe you're gonna have a funeral. It's gonna be a sad day. No, I'm joking. I would never do that. I'm a responsible dad. But hopefully you learned something new. Newton's second law. F net equals small. Oh, I don't even have it on board. Let me write it real quick. It's a very important equation. F net, the total force in a system, is equal to the mass times the acceleration the object is traveling in.
Why don't you write a little bigger?
I'm sorry. I'll write a little bit bigger, Jimmy. I'm sorry.
Thank you.
It's a very important equation. I don't want none of you to forget it. M-A. And hopefully you learned that physics is this huge concept that everything can be connected together, just like how I showed with energy. With the force that we found with Newton's second law, we were able to plug it into work, the work equation, to find the total work, and learn that energy in a system can be transferred into many things like potential energy and kinetic energy. And for your homework tonight, I want you to predict or come up with the theory of what Newton's third law is. I don't want any of you to use Google, because that's cheating. And a hint, why do you think the baby balanced when we dropped her on the floor? There we go, we're done.